Let's have a look at our family tree of the quadrilaterals. And there's the tree right there. Obviously quadrilaterals is all of them, and we branch down to all the different shapes as they become a little bit more specialised as we go down. So basically, if we want to classify a quadrilateral, we look at the particular feature that the shape possesses, and as we branch down, the more features the shape will have. So any property you know about a particular shape can also be used for any shape that branches off it. The example, did I put an example there? Yes, we did. So for example, a rhombus, whilst it has some of its own properties, we can also use any property from a parallelogram, because it branches off that, a kite, a trapezium for that matter, because trapezium can branch down to rhombus, and a quadrilateral itself. So let's look at these things in a little bit more detail. The quadrilateral, what do we know about quadrilaterals? Well, it's got 4 sides. That's about it, really. Well, it's got 4 angles. Not real useful that much when it comes to proving things in geometry. Okay, so rather than that, it's just a generalised shape. There's no specific properties. Right. Let's branch over to the kite. Now, the kite is the one where the adjacent sides, so you've got a pair of adjacent sides equal, and in fact there's 2 pairs of adjacent sides equal. We get that classic kite shape. The other thing we know about a kite, diagonals are perpendicular. Right, so the diagonals are always perpendicular in a kite. Some people tend to think that's a feature of the rhombus, but it's not actually a feature of the rhombus, it's a feature of a kite. But a rhombus branches off the kite, so we can use it for rhombus as well. Similarly, formula for the area of a kite. Again, most people think it's the formula for the area of a rhombus. It's actually the formula for the area of a kite. But again, the rhombus branches off the kite, so we can use that formula. So half xy, where x and y are the length of the diagonals. Okay, if I branch out a different way, I can get a shape which we call the trapezium. And its feature is, of course, that it has 1 pair of parallel sides. Not a heck of a lot that's interesting, other than we have our area formula, half perpendicular height times sum of the parallel sides. The trapezium then branches down to the parallelogram, where now, not 1 pair of parallel sides, in fact we now have 2 pairs of parallel sides. We know things like opposite angles in a parallelogram are equal. We know opposite angles in a parallelogram are equal. We know that the diagonals in a parallelogram bisect each other. And we have an area formula for parallelogram, base times height, where that height is the perpendicular height between the parallel sides. Okay. Now, if you had to prove a shape's a parallelogram, sure, you could show any of these points, but the other way of doing it is if you just got facts about 1 pair of sides, but you know they're both equal and parallel, that's enough to say the shape's going to be a parallelogram. Alright, kite and parallelogram. Parallelogram branches down to the rectangle. So now we get a little bit more specific. The angle in a rectangle is now 90 degrees. And of course, once you've got one angle equaling 90 degrees, all the angles are going to be, and you can easily prove that because of the parallel lines, you have co-interior angles and things like that. So all the angles end up being 90 degrees. Now the diagonals become equal. And area formula for a rectangle, base times the length, or the length times breadth, or however you say that one. Okay, rhombus branches off both the parallelogram and the kite. So it has all the features of the parallelogram, all the features of a kite. The other interesting thing about a rhombus is the diagonals now bisect the vertex. So always cut the vertex in half. Which brings us down to the most specialised quadrilateral of them all, the square, which by itself doesn't really have any features. It just has all the features of all the quadrilaterals. If you wanted a formula for the area of a square, there you go, it's the side squared. Okay, I didn't bother with any examples. Let's just get stuck straight into it. So there's 3 different exercises there. I picked a few out of, all on our different quadrilateral properties.